Alright, that's about right. Okay, I'm working on a chip A emulator here, and I'm basically just streaming it because I need an excuse to talk to myself. Alright, beautiful. I want to have, what the fuck, can I turn this to not be top chat? That's kind of gay. Anyway, yeah, live chat, there we go. Fucking despise top chat, but alright. Alright, I'm so hilarious. Okay. So right now, I'm running I have a chip A emulator right here. And this is a bit too loud for my taste for myself right now, so I'll turn it down for myself and turn it up for the stream. There we go. Nice. So right now we are looking at adding the fx1e instruction, which adds the register vx to I. So that's a fun time. So at the moment, I mean, we can already play some games. Let's just show that real quick here. So how about Pong2.ca? If we run that, we can see it's a Pong game. It runs extremely fast right now, but that's because I have not limited the clock. If I limit the clock, you see the real speed of it. It's pretty obnoxious. But that's not because of my performance, that's just how the game kind of is. It's supposed to run at 60 Hz. And these delays are caused by the program itself. And yeah, so that's pretty much Pong. We can actually control this a little bit here if we want to. It's quite difficult. You can see the left pedal is moving, and now the right pedal will be moving down as well, or you know, up. Doesn't really matter. So I'm using SFML for the inputs, and if you look in the profiler, there's really nothing that is holding us up particularly. There's just some SFML graphics stuff, but I already sped that up as much as I'm willing to do. And really the game logic is going to be in here. That's the emulate cycle one, so you can see that takes no time whatsoever. That little tiny thing there, it's my emulation itself. So honestly, that really doesn't make a big of a difference. So yeah, but if I want to run a different game, I haven't implemented all of the instructions yet because it's quite a bit and I have to implement them all by hand. As you can see, actually that's the wrong one in here. So I've already implemented all these instructions. And these are just part of the instructions that you just saw. So yeah, but what we want to implement now is the fx1e instruction, where x is the number of the register to increase. So this is what a program would look like, for example. It's pretty much what in Java you would call bytecode, or in the real world you would call a binary. And this is just a hex representation of that binary. So we have our, I hope music's not too loud. I can't see because people are not actually watching, or at all. I don't expect anyone to be watching, but I need an excuse to talk to myself. So fx1e, and I can also point back to the live replays, the replays of the live stream, or whatever the fuck they're called. So this would, for example, call instruction C, and with the arguments C0, 1 and 1, the arguments 0, 1, 2. If we look at C, it's going to be up here. That's going to be, no, it's going to be down here. Actually, C, X, and N, and it takes the register VX and sets it to a random number, logical AND with NN. Okay, this is a terrible example because that's actually really hard to understand if you don't really know that much. For example, I have an instruction FFFF. It's just 8 bits that say F. All bits are 1, basically. And that's a custom one that just breaks, that just causes this breakpoint here. I know there's fancy ways to do this, but I want to eventually maybe replace it with a manual signal call for an actual POSIX breakpoint, not just in here, so that it will actually break even while in release mode or whatever, right? It doesn't have to be run in here. It will always break with a SIG trace or whatever it's called, right? So that's a signal that gets called anyways. I'm just talking way too much. So we already have some F instructions, I think, so we'll just put that over there. So at first we decode the opcode, right? The opcode is basically always, this is an opcode, this is an opcode, this is an opcode. We just have to decode it, basically. And so I can actually show you an example here. If we just delete this right here. So let's just make a little program that's gonna put the number 1 in register 0, and it's gonna put the number, let's do 3 in register 1, and then we break so that we can actually debug it. So what happens, 6 is the instruction to move a piece of data into a register, right? This is roughly equivalent to saying, the code I just wrote is roughly equivalent to assembler, and I know this is not how you put assembler in C++. I'm just hoping that this will allow me to get some syntax highlighting. It's not doing it. Okay, never mind then. In that case, let's just type it in here. So in assembler, that would be, move, in this case, our register would be called V0, and then the value 0x1, right? That would be pretty much the assembler instruction. It's pseudo assembler in this case. It's not really real assembler. I'm not that familiar with any of the assemblers, assembly languages, so not really that much knowledge about the syntax and whatever. But basically the 6 basically just says move. Then the 0 is the register number, and then the data is 4 bits of data that we can put in the register. So in this case we put 0, 1 in there, and register 0, and then register 1 gets the data 0, 3, which is just a 3, and then we break. Right? That's my breakpoint that I set. And this is basically just binary right here. Like, it's just a different representation of 1s and 0s, but it's much easier to read. And so what we do is we filter the opcode, and we take the first bit, the leftmost, the leftmost 2 bits, and we look at them, and we see, whether those are match any of our patterns. So basically with this we end it, so we extract this first well, I'll call it first one of the letters in the hex code, right? And this might be 1, this might be 0, and this might be 3, or whatever else, D, E, F. And so we're looking for F because we want to add it to the F one. So there are codes like C that just don't have any other specifications. They just say C, and then you put in your data, right? So C, and then you put in X and N and N. That's pretty simple, right? Let me actually check that I'm in the right resolution here. Yes, perfect. That would be scary. So yeah, you see, in this case we extract other things. So in this case we extract the second, let's say character. It's not really a character, but you know what I mean. And in this case we extract the last two. If we read it, I don't have to tell you this every single time. It just doesn't really work like that, but this is how we do it. And I don't really know what to call these. So two of these are, yeah, anyways, so we get, in this case, for example, we push the, well, this is the shit example again with the random number generator, but there's other examples like the set, which is A something, isn't it? Or no, it's 6. Yeah, there you go. So we take the X and we push it into, we take the NN, the F here, the two Fs, filter that out. So we get these two NNs and push them into register number X, which is V index X. This just extracts this X, basically. All looks very complicated. I don't think really anyone is following right now, but for future reference, I'll keep this stream going, because why not, right? So let's just have a gander where my F is. Finally, we don't actually have an F, do we? Yeah, we do. We have a lot of Fs, so we definitely implemented that. So let me just search for 0xF. 0, 0, 0. Yeah, there it is. There's my switch for the Fs. No, it's not. There's that's a different one. Fascinating. I could have, there it is. See? That's in a weird position. I'll move that. It should be at the end because it's the last number, pretty much. Not pretty much, it is the last number, but I should put it in the end because that kind of makes sense a little bit. Like that. Okay, so we have 7, 15, 18, 29, 33, 65. And we need 1E to be added to this. So 1E is going to be here, roughly. It doesn't really matter, but Alright, thank you for the fucking motorbikes out there. It's great. Oh, yikes. Okay, so add Vx to I. Alright. 0x f x 1e adds Vx to I, and I is just one of those values that this holds as the index register. It's just a special register, just a special purpose register. You might as well use any other register, but in this case, it's kind of special. There are some functionalities, some opcodes that are specifically for I, so you don't have to so you can give it an X, a Y, and an I, which is otherwise quite difficult. So we want to add Vx to I. So literally, yeah, I plus equals Vx. So let's just do that way. So I plus equals, we can just pretty much do V, and then we need our X. Let's extract our X. Our X is in this position, third from the right. So we need to just take our opcode, and we want to extract the third from the right, like that. And then we need to push it right by 8, shift it right by 8, because we have these two there, that's 8. That's, this is 1 byte, and then this is 1 byte, and so we have to push it right by 1 byte to get this F over here. I don't know if that makes sense to you, but it does. So now we need to advance the program counter by 2, because we advance it by 2 bytes each, because each opcode is 2 bytes. There might be a better way to do it, but I don't really care. And for my sanity's sake, I still have these printf statements that tell me exactly what's happening, so I can kind of backtrack if something goes wrong, right? So, did I actually not set this? Okay, this should be invaders again. So let me just run this real quick. Actually, let's just finish this. So add v 0x x to I, and then that's just kind of a debug information that was gonna get cut out later when the whole thing runs, because it doesn't really slow it down at all. I didn't show that in the profile, but trust me, it didn't slow it down at all. So let's slap this in there. Alright. Beautiful. So this should do it. So if we debug run this, Space Invaders, beautiful. Not sure what I'm supposed to do here. Oh, that's cute. Yeah, that's the low frequency. That's a 60 hertz that we have on the processor. On the the virtual processor. It's quite slow, but that's pretty cool. Is this the actual game? This should be the actual game. This must be a huge program. This probably stores all the fonts and shit, because we only store fonts to display the numbers 0 to 9 and A to F. So, everything hex. So that's kind of weird that it has all these. Not sure what we're supposed to do. Are we supposed to press something? I think we are supposed to press something, so it's kind of a let's play now. Okay, hold on. Let me kill that. Let me increase the frequency to 240 hertz. That's much more fancy. There you go. Just leave this in the foreground here. Still trying to figure out why it's that slow. Like, I don't know if it's probably supposed to be that slow. I have to look at some demonstrations. I haven't actually had a gander at those. Programmed by David. I don't actually know who programmed this. Oh, of course, the guy. Oh no, it's not the guy. Not the guy that made the chip, the chip 8. You must press. Come on. Oh my god. This is unfucking bearable. Let's just run at maximum frame rate. You must destroy the invaders to prevent the invasion. Okay, that's a bit too fast, maybe. Yikes, dude, what? Let's do like 800 hertz. God, that's just so fucking slow. Like, what the why? Why? Just why? 1400. Oh, that's better. Space Invaders. Programmed by the, and this might not be the best game ever, but it's running in an emulator that I just made like today. It's 5 p.m. now, and they started making it at about 7 a.m. So I've been sitting on this all day, which is, it might be sad, might not be sad, I don't know. 4 and 6 with 5. So 4 and 6. Oh my god, what the fuck are 4 and 6 again? Okay, it should be starting now. Oh, it's not starting automatically. Wow, okay. Do I have to press 0? What key can I press to start this? I'm pressing. See, there's not a lot of keys in this, so... Oh, there we go. We're in. Alright. There is some key with which we can... So it's 1, 2, 3, 4, 5, 6. Oh, we don't have the opcode. Yeah, I was about to say this froze. Completely frozen, like we can't even close it anymore, right? So what happens is we broke because we are missing an opcode here. And that's completely expected because I haven't implemented all of them yet, but I kind of am doing it on a game-by-game basis. So I don't implement, work on implementing something for hours that, I mean not hours, but like for, 30 minutes that I don't actually need. So, if you have a little look at these messages here, if you want to, you can see that we have quite a lot of debugging information. So for example, this is returning from subroutines, this is storing the least significant bit, shifting right by 1, the register v1. Then we see the program counter, and then we see the next opcode and what it interpreted that as. So 2369 was interpreted as calling the subroutine at 369 from 35b, and then in a second we'll see this return 235b, well 235 C probably. Oh, that's weird. I mean, this is right. Yeah, no. So from 35b, then it's doing this is a subroutine that's running. This right here, and then we return from the subroutine with EE, which is a special one. And then we have, oh my god, then we have 35D, which is the next program counter, that the program counter after the subroutine has been executed. Then we see another subroutine is being called, and so on and so forth. So let's kill this application. Let's actually quit this and go and see make release, and then hex here we're gonna open that, and this is actually the entire program here. That's quite large, but not as large as you might think. So as you can see in the beginning, there's a string, which is interesting. I don't know how it is interpreting that. What is it doing? It's probably gonna jump, right? Is this a jump statement? 1, 2 to 5? I don't think it is. Pretty sure that's not a jump statement. Oh, it is. 1, 2 to 5. Okay, that's how he's doing it. Okay, so he has his name in there, and the version. Yeah, David Winter. So this is 1225, which jumps to 225 in hex. And 225 is 25 hex offset from the start, because the start is 200, because the 200 in hex is 512 in decimal, and so the first 512 bytes are actually reserved for the operating system, or the data of the emulator itself, which it's not occupied actually, but it's not really used. So you could put some pre-built functions there. You could put some helper functions in there, some extra functionality, some more data, more fonts maybe. It just holds the fonts that I talked about, the hex fonts basically. Yeah, this rest is just mumbo jumbo, which is just program code really. But you can sort of see. I mean, it's impressive that he has all this text, all those sprites in there. Fascinating. It's a good amount of work, I guess. So this is all bullshit right here until like about here or something, I thought. where he has a probably null terminating thing, and then he kind of starts with the next instructions and runs the game, and then he waits for a certain input while he runs something else. So he has a loop, and then he waits for input in order to break out of the loop, stuff like that. So it's very impressive program. I would say it's more impressive than writing the emulator that it runs on, but it's subjective, isn't it? So, as you can see, oh, I closed it. Okay, great, I'm a genius. We also have Tetris here, so we might play that in a sec, but yeah, right now we just have to implement the next one, which is going to be, so it broke here, and it said unknown opcode not implemented E09E. So if we actually run this again, we'll see that happen. I don't know which key I pressed there. It's W, okay. And it immediately dies. And so when it dies, we actually break here. And if we look at the view, we can see in the chip that where is it? What am I looking for? The opcode is also here. So if we didn't have this information, if we didn't have print statements, we would still, when it breaks in debug mode, we'd still actually know this. Even though this hex view is a kind of weird feature you have to enable in CLI during doing some weird shit in the configuration, but it's not default, weirdly enough, but yeah. So, am I offline on YouTube? That sucks. Well, at least I'm online here. Nobody's watching, but you know, I can actually hide that, that's fun. Alright, so that's gonna be that. So E something something E. E09E is what we want to implement next. So E09E, and I've been following this tutorial obviously, but it only kind of outlines roughly what you have to do, and the rest you have to figure out yourself. E09E is gonna be here. E09E skips the next instruction if the key start in VX is pressed. So obviously, this is exactly what we're looking for, right? This I've already implemented, I think, which was used at the beginning to say, you know, do this until a key is pressed. Basically, it skips the next instruction, which might be a jump statement, right? So, but I guess that makes sense. I'm pretty sure I already implemented one of the E functions. Yeah, exactly. The A1, the skip next instruction, if the key is not pressed, which actually make that clear. And so basically what we can do is we can just copy and paste this. So I can't be bothered to write it all out. That's going to be E9E, EX9E, so there we go. 9E. Let's make this more explicit. It is not pressed. Is pressed. And so we go pressed. It's not equal to 0. And the reason we do it's not equal to 0 instead of equals 1 is because we don't actually know what value is in there. Because it's my implementation, I'm going to put 1 when it's pressed and 0 when it's not pressed. But it might be something else. You know, if it's a joystick, it might have more than one value that you might want to put in. You might have an extra instruction that asks for the value or something like that. So this just says, is it 0 or is it not 0? That's what the check is, not if it's 0 or 1. So we do that, and we do that, and that should be enough. Okay, it's press W, and it starts working. And we lose. So, I mean, obviously that's because it's quite fast and I don't actually know the controls, but, you know. So we got a bunch of opcodes here that are not implemented. And it didn't actually break, probably because it wasn't running in debug mode. Oh, why are we not breaking? Should be breaking. F00. Oh, I know why we're not breaking, because there are... Yeah, this one. Yeah, that's what that is. That's kind of stupid, but I know. Yeah, this is super fast, and we lose, and F00A is not implemented. So, case 0x00, 0a, 0x fx 0a. What does it do? What does fx 0a do? Key press is awaited, then stored in vx. So this is a blocking operation. Oh god. This is quite difficult to implement, isn't it? So, this awaiting is what we have to actually implement. So, so how could we do that? So right now, we call the emulate cycle right here, which emulates one clock cycle, is what that means. So, let's see, if we do actually emulate cycle, we could put something around here. We could have a halt flag or something. Yeah, let's add a halt flag to the chip. So halt flag. Actually, so if chip A dot, what do we call it? Halt flag, yeah. If that is set, then what we want to do is we want to say, actually we don't want to say anything, we just want to halt. What do we still want to do? Nothing really. The whole process, the whole thing, all instructions halted. So this includes all instructions like this. Oh, actually, one way we could do it is we could not advance. Oh, actually, that's beautiful. So, if key v opcode, we want to extract that one. Right shift by 8, we know this procedure very well. 0. Then we want to say PC plus equals 2. And else we halt. So we just run this over and over and over until the key's pressed, right? Because otherwise we don't increase the counter here conditionally, right? If it's not 0. Yeah, if it's not 0, then we... So I don't know what key it's waiting for. It just kind of sucks, but, you know. We could just do it ourselves. Wait for key 0 in our test thing, but I don't think I'll do that. There's also delay timer, stuff like that, but it doesn't really work. I don't know. Where was that? Where was that? There. Key up. Key press is awaited and then stored in VX. Oh. Oh, until any key has been pressed. Oh, yikes. Well, I mean, it's not too bad, is it? We could handle it in here. That would be way fancier, you know? Saying for key, sorry, for unsigned, what is it, char, okay, fuck, we can't do that. Unsigned and, actually, how many do I have? 16 keys? Yeah. The reason I know that so sure is because it's a hex keypad. Hex means 16 in this case. Hexadecimal, 16. So, if this is not actually what we want, right? We want if anything, like any key is pressed. So if key is not 0, then we want to advance the program counter and break. Otherwise, we just continue. I wanted to actually see. Oh no, okay, that only works in Python. Okay, so we break out of that loop. Okay. Oh god, this is. Let's just do that. Well, it's actually not F, it's E, is it? Well, it's F because we don't actually want to check for F because F itself is. Oh, actually, we do want to check for F. 0 and till F inclusively, right? Because we do have an F, right? We don't have. Yeah, we do have an F. We have 8 by 8, so we do have an F. Pretty sure? No, we don't, because they're indices. I'm retarded. This should be blocking. Don't forget to put the new line there. Then we just say forget the new line. Alright, let's see if this works. So this should all work, right? We do this. We die. It says blocking until key press. We press a key. Okay, so it's literally just waiting for any key to be pressed. That's cool. Did you see that? So it is actually, once we go game over, you can see down here it's saying blocking until key press, right? And then once we press literally any of the keys, any of the 16 keys, we go back to this. So that's pretty cool. I enjoy that. I think that's cool. Okay. Kind of sad that nobody's watching, you know? It's kind of sad. I think YouTube is down actually, but the YouTube stream is down, but you know. So yeah, this is Space Invaders, I guess. Now let's turn on the clock again now that we know that we don't have to actually wait through the entire thing. Let's put it down to 120 Hertz. That was quite acceptable. That's acceptable, yeah. Okay. Let's actually see. Can we move a character? How can we move the character is the question. Not if, but how. Oh, there we go. We can shoot. Aha. Get fucked. Nerd. I don't get it. Anyways, it is running. And we don't have any instructions that I'm missing here. So that's good. Let's go to the next program. What else do we have? Tetris. It's probably gonna have some stuff missing because it's quite the game, you know. Okay, what the fuck? Oh, ha! See? There's one missing. 91C0. (91C0) it's gonna be 91C0, 91C0, 91C0. That's this one. Skips the next instruction if Vx doesn't equal Vy. See? It's so many logic instructions missing, I think. Which is fine, I mean, you know, I'm still working on it, but there's so much work. And I've been working much faster today, like, than this. Like, retarded fast. Most of this I wrote in, like, 3, 4, 5, 6 hours, something like that. I mean, that's a pretty bright, like, broad thing, but, you know, still. Alright, so we want a 9. Do we already have a 9? 8, 9. Do we not have a 9? Oh, there's only this one statement is a 9. Okay, never mind then. Let's actually implement that right away. So k0x9000, that's gonna be 0x9xy0. Actually, we have to say what this is. Is this the blocking one? Which one is this? Oh, this doesn't actually say. No, we were missing the different one. We were missing the blocking the blocking one. Where is it? I just added it. Where is it? Not there. It's gonna show me in the thing here, isn't it? Oh, it's this whole thing. Nice. Actually, oh, whoa. Alright, that's not what I wanted. It's right in here, isn't it? Yeah. Block until key press. So this might not actually be the best way to do it, but it fucking works. So, we only increment the counter if we get a key press. Not getting a key press leads to an infinite loop. Alright. Okay, let's do this. So skips next instruction if Vx not equal Vy. Break. Alright, so don't forget to advance the program counter. Skip the next instruction if Vx doesn't equal Vy. And you might think, you know, where I did those, like, skipping instructions, I actually split this into two. Could have said, you know, plus equals 4 and then put this in here, and that would work, right? That would be the same thing. But I like it this way because it's just more clear, sort of. So we skip we skip one instruction, and if we have this specific requirement fulfilled, then we skip an instruction and then skip an instruction. So it's probably the same way I'm going to do it here, because that's just quite fancy, and it makes it kind of better, like easier to understand that we always advance one instruction at least, right? We always need to do that, so that makes it super clear, in my opinion. Let's see here. Yeah. Alright. Some private DMs that I'm not going to read right now. It's a bit, you know, scary. So, Vx doesn't equal y, Vy. Okay, so we just do... See, this is where my brain freezes because I'm streaming. 0x0f00, or right shift by 8 is not equal to v. Actually, is equal. No, is not equal. That's the requirement, isn't it? Opcode and 0x00f0, right shift by 4 because we only have 4 bytes there, 4 bits there, right here, that's 4 bits, and that's a byte. That's why we do that. PC plus equal to. So let's get some documentation going. Skip instruction if v0x% not equal v0x%x, and obviously you can make this always true or whatever you want by just applying x and y to be the same number, and it doesn't really care, and that's the beauty of it, isn't it? I mean, not that it would be like useful, but it's still fun to think about, to, know that that is possible. So let's just copy paste these over, because there's also no problem that these are actually running way out of the line here. I'm kind of restricting myself to only 80 colons, like this, right? Like this right here. This is the maximum length for a line that I want to have, because it's compatible with older systems, shit like that, CRT displays. But I just can't be bothered with my print messages because they get long as fuck. And the reason I'm using printf is obviously because of the hexadecimal, the easy hexadecimal format. Not interested in the standard cout way, even though this is C++. As you can see, this is CC file, not a C++, not a C file, and this is an HH file, and an H file. You can also use CPP, C++. I don't know what else there is, but I mean, you can also call them .c and still use the C++ compiler on it. There's all sorts of shit you could do, but CC is sort of a way to signal that it's C++, multiple instructions. Just so it says something there. Multiple. Alright. Oh yeah, we're missing the printf. These are 4 spaces, by the way. So this is going to be true. I like to put that in, so, as I said, I'll remove that later, but just so I kind of see what's happening. Because I have actually tested all the other functions with my own little programs, made sure they behave as they should, stuff like that. So, yeah, that's going to be that. How the fuck does this work? I mean, I know how Tetris works, but it's not really making a bunch of sense to... Okay, that's not happening. Yeah, that's not happening. I'm not sure how to move the things. Because as I said, these controls are completely, like, weird. That's kind of weird. Am I doing something wrong? Is it my program that's fucking up? I think this is not. This is so fucking scuffed. What other programs do you have? Are these all? And you have the original Pong one that didn't run for me. I mean, it does run, but it's not particularly good, I guess. Look, it's quite weird, I don't know. It's very slow. No idea why that is, but yeah. So let's get some ship A programs here. There's not a lot, but there's a few. I can test that. Otherwise, I'll just go through the list and just start programming each little feature myself again. Oh god, I'm tired. Yikes. Obviously, you know, you could make a GUI for it, debugging GUI. It's all been done before, but this looks cool. Can we download these? What is this? Okay. Can we git clone that? I've never tried that. Yeah, it does actually let me do that. Okay, I didn't know that. I guess this is just a master, isn't it? I don't know. No idea. How big are these? Yeah, I was about to say, okay, that didn't work. Jabate is the repository they want to clone. You just test programs, really. Let's see. Why is this so complicated? Why is this so split up? Maybe I should split mine up too. Oh, he does actually have a stack. This is just clearing it, isn't it? Yeah. Okay. Yeah, I don't know. This is a weird implementation. I like it the way it is for me. Like, okay, so he has, you know, a legitimate, like, he probably has a yeah, okay. How does he do his window? Oh, the STL, okay. Fair point. Fair enough. Oh, nice. It's empty. Alright, so we just really are interested in the demo. So it's going to be in Jabate, demos, Sierpinski, for example. Let's do that. It's going to be Jabate, demos, God, fucking damn it. And I hope that this is not a completely different, like... Is that implemented in the original Jabate? See, that's my problem. Like, there is a super, like... What is it called? A like, super thing. Whatever, F005. Oh, F055. Oh, of course, yeah, because it's recursive, it probably wants to store some shit. Excuse me. I actually didn't implement that. That's embarrassing. Okay. I thought I did. Okay, this stores v0 to vx to memory. Probably starting at I? Yeah, starting at I. See, you couldn't do this otherwise. Like, you need the special I pointer. Otherwise, you would have to have a more than, what is it, 16-bit opcode set. Because you would have to give more information, and this way you just put that information into I, and then it just knows that it needs to take it from I, which is great. The offset from I is increased by 1 for each value written. Oh, okay. That's the same as this, just in reverse pretty much. Let's just copy this. And so what we want to do is, instead of doing this, we want to do that's what we want to do. I haven't actually tested this function, but yeah, it actually says to do untest it. Test me. I'll make this a bit prettier. Doesn't have to look like cancer, does it now? Yeah, looks good. Filled. Filled memory range with values from, there we go. Then we just have to swap some stuff around. So that goes to the back. I love this music, holy shit, it's so good. I'm actually offline. Okay, that's embarrassing as fuck. Well, I'm not offline on Twitch, so see it on my phone. 5010 is not implemented. Okay, mister. What the fuck is 5010? Oh, yeah, go away. 5010 is going to be skips the next instruction if Vx equals Vy. So that's a new one. Obviously, we can pretty much copy and paste that code from, what is it? There's a different one that is like that. Skips the next instruction if Vx equals Vy. It's the same as this down here. There. 9xy0, 5xy0. Okay. So let's grab 9xy0. And put that in here. It's going to be 5xy0, right? Yeah, that's the only 5 instruction, so we can do it like this. So if that equals, look good. Not even going to bother testing it. And that's a Sierpinski triangle right there. Oh, it might actually need some other stuff, but this is recursive. So actually surprised. That doesn't really look okay. Looks like it's missing something. But I mean, maybe that's deliberate, because it does look kind of shit with the big bold lines in between. I mean, it is a Sierpinski triangle in the end. Sort of. So, clock speed. Not about to wait for that. Actually, this is fascinating. Let's profile this. I mean, this is a really good job that someone did here. Unless it's hard to code it, but I don't think it is. That would be a bit of a, a bit of a scam. So this is the Sierpinski triangle. It's quite a beautiful site. There we go, last line. And now it's entered in a continuous loop, as you can see down there. It's just jumping to the same address. This one, just look out for that. That's going to stay the same. Now, really, no matter what we do, so we can press keys. It's probably not going to do anything. So yeah, we can close this. And now let's look at the profiler, which is always fucking interesting. Is there more? So let's have a gander. Anything changed? This is just debugging stuff. Actually look at the emulate cycle thing. See, right? Actually the I/O took longer than most of the processing here. Inline I/O overflow. So much fun to look at. I don't know why it's so fucking small though. It's a bit of a bummer. Call tree. Method list. Yeah. The rendering is all the way up there. The rest really doesn't make much of a difference. And I optimized the shit out of the vertex array. Like for my, like this is optimized for all I care. Like we do create 4 times 64 times 32 vertices per frame, but it's not like I give a shit. Performance is not heavily degraded by that, as you can see. As you can see, that's the entire kind of time, right? And this is the vertex creation, so it's not retarded, okay? It's not retarded. It would be better if we could do without it, but we can't, so. These are not constant, these are changing because the color is changing, so I guess we could make it like a lookup table of these, and just not really worth it. Like the performance increase is not worth it at all. Oh, this there's an inline printf. What else do we have? Another printf, blah. Oh, what do we have here? libsfml graphics operator, window display, swap buffers. Yeah, this, yeah. This is the reason I'm using SFML here. SFML, sorry, here is that it is using pretty much direct OpenGL, but I don't have to worry about it because OpenGL is a fucking whore. You know, I'm not gonna lie, it's pretty shit. So there's actually an SF clock running. Oh, probably for the timing of the clock, right? Well, it is the clock that's being timed, I guess. Fascinating stuff. Love this stuff. I just today installed the performance profiler thing. It's a bunch of unknown here. I don't know, this must be debug information. There's some heap, some stack somewhere. One of these is stack. There, stack. I don't know. It's weird. I don't really get it, but it's not like I care too much about it. So let's kill that. So that's one of the demos. What other demos do we have? We have the Maze, David Winter, Trip 8 demo. Let's look what the Trip 8 demo is. Trip 8 demo. Okay. That's kind of cool. Does it repeat? No, it's not repeating. Okay. Beautiful. And that's super cool, but yeah, so Trip 8. Fascinating demo. What do we have? We have some fonts. Oh, actually, is it reading TTFs? Oh, I didn't think about that. IBM logo, yeah. Picture. This is a fascinating one. Because I'm not sure about this one. Can I like copy relative path? There we go. Let's get rid of that. Because I can't be bothered to type that shit out. Debate picture. Is it loading a picture? Is that what it's doing? I don't think it is. That would be pretty nuts, though. Huh. Clock program? BMP viewer? Really? Fishy. That looks like fun. Sounds like fun anyways. We'll see about that. Looking fun, but maybe it's literally, yeah, it's literally a fish. Alright. Yeah, it's an infinite loop of a fish. Okay, thank you very much. I mean, that's cool and all, but not like I care that much. This looks fun. Copy route of path. At this point, I might as well just write it out, but you know, I'm willing to put in a lot of work to be lazy. Aw, that's cute. Is he using the random number generator? It probably is, because... Is it? Just doing some division. Oh. Oh, that's fun. It's running on my emulator. Isn't that crazy? That's crazy. I mean, this is a these people are complete fucking nuts. Like, I mean, who says I'm not nuts, but that's particles. That's fun. I don't really know why you would make it, but that's certainly awesome. Mind-bogglingly awesome. Wowzers. Yeah. Maze. That's actually run one of these mazes. I think I know these. I think I know this program. It's like one of the originals. I think David Winter is the guy that made the chip 8. Well, invented the chip 8 pretty much. That's a maze, alright. Does it just generate the same one every time? Oh, no, it doesn't. Is it solvable? It's a beginner, so... I mean, it probably isn't. It doesn't have a start or an end, so... I don't know what would be solvable about it, but... Okay, so it starts by moving something into I. And it does some random shit. Skip one, move, draw, add, no carry, skip one instruction, move, jump. Oh, okay, there's quite a bit of logic here. Oh wow, I was about to read that all out. Yeah, no thank you. That's a lot of shit though, to be honest. Like, that's pretty impressive, to be real. Real with you, Chief. That's pretty impressive. Look at this. And then, yeah, we just have an infill loop. So that's cool. I'm wondering what emulator I'm going to do next, because now that I know kind of how it works, and I got a little bit of, not experience, oh, well, I guess it's experience in a way, isn't it? I can probably do some other very, very simple ones. Maybe make my own one. We'll see. My own little programming emulator thing, whatever. That would be cool. I'm very tired, but that's worth it. That was so worth it. So from almost 12 hours of consecutive coding on this thing. Well, not consecutive in the, like, I did a lot of reading, I did a lot of trying to understand. I ate something, so it's not, you know, not super, like, 100%, but it's 12 hours from start to finish, so I guess that counts for something. Anyways, hope you guys tried it, and I'll get off now. And I'll stream something else someday when I start the next project, probably. Gonna record it and stuff like that as well. Alright, talk to you guys later.